The general conviction among most researchers is that the speculation of how things came to be stays the major clarification for the early times of the universe. This hypothesis joins the progression of stars, planets, and so forth, life on those planets, including ourselves. Not enduring its odd name, the Big Bang, it offers an enlightening assessment concerning what could have occurred at first. The universe was thick in a short space, more thick than a pinhead with particles thickly packed. From this second, a giant effect of matter and energy happened, known as the Big Bang. This event, happening billions of years ago, set up the fanning out of vast history. At any rate, advancements in logical information have set off growing anomalies with the assumptions of this theory. When NASA sent off the James Webb Space Telescope, the largest and most advanced space science observatory ever, researchers estimated that its discernment would confirm the theory of the universe's origin. Unfortunately, after only 1 year in space, the telescope surprised experts with its ability to peer so deeply into the universe's past. The James Webb Telescope's shocking limits have revealed countless galaxies, going as far back to a time so old that it challenges how we could interpret the universe's origins. This disclosure has lighted an intense assessment concerning what existed before the Big Bang. One key moment in this mission happened when cosmologist Rohan Natu, working with data from the telescope, suddenly found a galaxy from just a brief time after the Big Bang, making it the most distant universe ever seen. Natu's discovery sent shockwaves through established experts, highlighting the surprising abilities of the James Webb Telescope. Its huge goal to change our viewpoint on the universe has just barely begun, promising to uncover stunning insights into the earliest periods of the universe's existence. This period, scarcely studied beforehand, holds the key to understanding the development of the first stars and galaxies. The telescope's revelations have clashed with basic theory, uncovering galaxies with attributes surpassing past assumptions. This great flood of early galaxies has touched off a storm of scientific inquiry, testing experts to reconcile these revelations with existing theories. As researchers grapple with these discoveries, they face key questions about the very nature of the universe and the forces that shaped its development. Beyond the James Webb Telescope's advancements, which are unsurprising, it is found 1.5 million kilometers away from Earth, protected from ordinary interference and cooled to near absolute zero by its tennis court-sized sun shield. The telescope incorporates a tremendous segmented mirror and incredibly sensitive instruments designed to reveal details of the early universe, recently hidden. This period, known as the cosmic dawn, occurred around 200 or 300 million years after the Big Bang, marking the moment when the first stars and galaxies began to form. The process by which this unfolded remains a subject of great investigation, with theories ranging from the effects of dark matter and dark energy to the interactions between star-forming gas and dust. The telescope's view of galaxies from the cosmic dawn presents a unique opportunity for cosmologists to test how they could interpret these complicated elements. By investigating these ancient galaxies, scientists can either confirm the validity of their current models or uncover gaps in understanding that could lead to major new discoveries. At first, the telescope was expected to observe only a few faint and small galaxies in its pilot studies. However, reality has far exceeded these expectations. The telescope's early images of the distant universe revealed an abundance of galaxies with ages, sizes, and brilliance levels that defied all estimates. This surprising surge of early galaxies has sparked a race among space experts to establish new standard records for the earliest known cosmic systems, with new discoveries emerging regularly, leaving standard specialists in wonder. Following the James Webb Telescope's discoveries, subject matter experts and observers have rushed to study the existence of these surprisingly advanced early galaxies. Some hypothesized that errors in the telescope's interpretation of huge observations could be responsible for these startling discoveries. That said, the consensus remains that these revelations represent a paradigm shift in how we might interpret the early universe and provide exciting glimpses into the potential for boundless progress. The new discoveries from the James Webb Space Telescope concerning galaxies have raised key questions about the nature of the universe and tested the assumptions of standard cosmological models. While some specialists are examining whether these insights can be reconciled with existing theories, others propose that they may be the first signs that the universe is far more complicated and perplexing than previously imagined. The pivotal question in play is our fundamental understanding of how the universe we know emerged from primordial chaos. The early revelations of the JWST could reshape our essential ideas of cosmic history, uncovering insights not just on distant galaxies and old structures, but also on the very nature of our own Milky Way. As Mark McFan, Senior Scientist for Science and Exploration at the European Space Agency, puts it, "You build these machines not to confirm theory, but to break it. You just have no idea how it will break." The origins of the JWST can be traced back to the Space Telescope Science Institute, STSCI, in 1985, even before the Hubble Space Telescope was launched. At the time, G. Weir, then head of STSCI, was tasked with envisioning what might come after Hubble. Despite initial doubts, Weir and a small team began laying the groundwork for what would eventually become the James Webb Space Telescope. Unlike Hubble, which primarily captures visible light, the JWST was designed to observe in the infrared spectrum, allowing it to peer much further into the universe. This capability is crucial for studying distant galaxies whose light has been stretched into the infrared due to the expansion of the universe, making them invisible to telescopes like Hubble. With its massive cold, star-like mirror, the JWST became the premier tool for uncovering the secrets of the cosmic dawn. The need for the JWST was highlighted in 1995 when the Hubble Deep Field observation revealed countless galaxies in what was once thought to be a void patch of sky. This discovery illustrated the richness of the early universe and emphasized the need for a telescope capable of probing much deeper into cosmic history. After 20 arduous years of development and a cost of around $1 billion, the JWST was finally launched on December 25, 2021. By July 2022, it was ready to begin its most pivotal year of scientific observations. Early initiatives, such as the Early Release Science Program and the General Observer Program, were specifically designed to search for early galaxies. While initial expectations were modest, the results far outperformed them. JWST observations have tested existing models of the early universe, revealing galaxies that challenge conventional cosmological assumptions. These remarkable discoveries underscore the importance of pushing the boundaries of scientific inquiry and highlight the extraordinary capabilities of cutting-edge technologies like the James Webb Space Telescope. As scientists continue to analyze JWST data, they may uncover further insights that challenge and expand our understanding of the universe. When the first data began rolling in from the JWST, cosmologists were eagerly awaiting the results. Many had been preparing their data analysis pipelines for this moment for years. Rather than following the traditional peer review process, which typically takes months, specialists decided to share their discoveries on preprint servers like AR14, a platform for research papers that have not yet been peer-reviewed. This approach allowed for a new form of peer review to take place through social media platforms like Twitter, where established experts could rapidly discuss findings. Rohan Natu described this process as science by press release, and the ensuing storm of conversation was both intense and unprecedented. However, there were concerns about the potential drawbacks of this rapid spread of results. Klaus Pontypool, a JWST project scientist at STSCI, warned that while the quick sharing of results facilitated rapid dissemination and discussion, there was also the risk of overwhelming the process. The general understanding among most experts is that the theory of how things came to be remains the fundamental explanation for the early times of the universe. This hypothesis combines the development of stars, planets, and life on those planets, including ourselves. Despite its odd name, the Big Bang offers a compelling explanation for what might have happened at the universe's origins. The universe was densely packed into a space smaller than a pinhead, filled with densely packed particles. From this moment, a massive explosion of matter and energy occurred, known as the Big Bang. This event, happening billions of years ago, set up the unfolding of cosmic history. However, changes in scientific knowledge have led to growing anomalies with the assumptions of this theory. When NASA launched the James Webb Space Telescope, the largest and most advanced space science observatory ever built, researchers speculated that its observations would support the theory of the universe's origin. Unfortunately, after just 1 year in space, the telescope shocked experts with its ability to peer deeply into the universe's past. The James Webb Space Telescope's remarkable capabilities have revealed galaxies dating back to such ancient times that they challenge our understanding of the universe's origins. This discovery has sparked a serious investigation into what may have existed before the Big Bang.